So let's look at some more examples of finding the gradient of a curve at a given point. So for this one, if y is equal to 11 minus 2x cubed plus 4x, we have to find dy by dx when x equals negative 3. So, as you might guess, the first thing we're going to do is to differentiate this. So if y is equal to this, then we're going to write dy by dx equals, and now we have to differentiate it. So negative 2, well, first of all, 11 when we differentiate just gives us 0, so we can ignore that. And then negative 2x cubed, the 3 multiplies in front, so we get negative 6x squared. And then 4x differentiates to just plus 4. So this is what our dy by dx is. And we have to find dy by dx when x is equal to negative 3. So we can say when x equals negative 3, dy by dx is equal to, so we got negative 6 times negative 3 squared plus 4. And negative 3 squared is going to be the first thing we do, and that's equal to positive 9. So we got minus 6 times 9 plus 4. And that's minus 54 plus 4, which is equal to minus 50. So we're saying that the gradient at this point is equal to negative 50. And let's check with our calculator to see if that's right. So we'll bring in the calculator and let's type in the function. So we've got 11 minus 2x cubed plus 4x. Alright, so I hit graph, and I think my window is a bit wrong, so let's make the window along the y-axis a bit bigger, so maybe minus 10 to maybe 40, and see what it looks like. Right, so we can see a bit more of it now, and we're interested in the point x is equal to negative 3, which is just off the screen here. It's actually going to be just above here, but I don't think it's going to matter because calculating things, that part of the function doesn't have to be on the screen. So if we do second calc, we'll get to dy by dx by pressing 6, and then we're going to type in negative 3, and that means that x is equal to negative 3, and I press enter, and I get that dy by dx is equal to negative 50, which is what I got. So that's good. I'll put that to the side. And let's do the next question, which is find the gradient of the curve y equals 2x brackets 6 minus x squared at the point 1, 10. So first of all, we're going to have to differentiate this. Oh, but before we can differentiate it, we have to multiply out the brackets. So let's rewrite our function as 12x by multiplying this by this, and then we're going to multiply 2x by minus x squared, so that gives us minus 2x cubed. So all I've done is multiply out the brackets here, and the next step is to differentiate it. So dy by dx in this case is going to be equal to 12 minus 6x squared, and the point we're interested in is 1, 10. So that means that the x coordinate is 1 and the y coordinate is 10. And we don't really have to worry about the y coordinate because all we have to use is the x coordinate. So we extract the information that we need and say that when x equals 1, dy by dx equals 12 minus 6 times 1 squared, which is just 12 minus 6, which is equal to 6. So that's the gradient when x equals 1, and let's check it with our calculator, or we could have just done it with a calculator to start with. So let's type in the function 2x, put it up a bit, and then in brackets we've got 6 minus x squared, close bracket, and let's see what the graph looks like. Okay, and let's calculate the dy by dx when x is equal to 1, and press enter, and it tells us that it's pretty much 6, and 6 is what we got, So that agrees with the calculator.